Okay, apologies, Bailey, that I started a little bit late.
What's up, Bailey?
I've only been reviewing so far what we talked about last week. So last week's video should cover this. We've been talking about the age of the Earth. There's a huge difference between the biblical age of the Earth and the age of the Earth assumed by evolutionists. Why do evolutionists think it took this long to? Excuse me. Let me rephrase it. Why is it so important for evolutionists that the Earth be this old? Yeah?
Because that's like the year like the dinosaurs were created.
Okay. Sorry, I was okaying that. I was okaying that phone. No. Well, I wasn't okaying that phone. That's what I was responding to. So it's not quite right because they believe evolution. The theory of evolution believes that all life started from one single-celled organism. Very simple thing. They don't know how it came to life. You're not allowed to ask that question. But from that single-celled organism came other single-celled organisms and others and others. And after millions of years of reproduction, they changed slightly. And the driving force for the change was that some of them had something that helped them to survive better. So let's suppose that this little blob here started to grow hairs. You know, there was one that for some reason had hair-like protuberances from it.
It's the only one that hit puberty.
And the presence of those hairs enabled this particular blob to survive better. And when it reproduced, it made more hairy blobs. And eventually, since there's limited food to eat, when it came time to compete between the new version and the old version, the new version got more food, the old version starved, and over the course of many more generations, the old version ultimately died out, and the population evolved into this new version. And this does not happen very quickly. This takes a very, very, very long time for especially something as major as this. Like, this isn't just a slightly larger blob or something like that. This is something with a qualitatively different thing. There were probably countless other variants of this blob that were worse than this one, and so they just died. But this one was better, and it took over the population after many generations. And then that became slightly better, and then slightly better, and then as they moved to different environments, we'll talk more about Darwin's theory of evolution later. But the point is to go all the way from molecules to man, here's man down here, takes an extremely long time. It's already statistically very unlikely that this would happen over the course of a billion years. But it is downright impossible that it could happen in as short a span as 6,000 years. The amount for a population to change in 6,000 years is not very much. You can breed different kinds of dogs. You could, maybe like a single horse-like ancestor might evolve into zebras in one environment and donkeys in another. But you're not going to get something like a horse. You're not going to get something like a horse evolving into a bird, or into a fish, or a fish evolving into an amphibian. That's not something that happens over the course of a few thousand years.
You could do it though.
Theoretically, I mean, DNA, as far as we know, is just like a really, really long computer code. And evolution happens in part when there are mutations in DNA that change the code slightly. And if a random change happens to be good, then that takes over the population because it outcompetes the bad stuff. So yeah, we'll just say this is better than this. So this dies out. So that is evolution. And the reason why this is so important is because if the Earth is not billions of years old, then this whole theory is impossible. So this theory relies on the Earth being this old. And so people will defend the old age of the Earth to the bitter end because it is the foundation of their system of faith, their belief that mankind is ultimately a cosmic accident that evolved from nothing. So we talked about how there's this huge difference in the age of the Earth between our worldview and the evolutionary one. And then we talked about methods of dating. You guys remember why we were talking about dating methods?
I get lots of girls.
Yeah, not that kind of dating. I knew that was coming.
Whoa!
Whoa!
Whoa.
No Diddy.
Okay, so
I don't have good experience with women.
anyway, okay,
You mean
so
men?
we started talking about dating because we asked the
What do you
question.
used to do?
We asked the question, what is the evidence that the Earth is billions of years old? And one of the main pieces of evidence that people talk about is dating methods. Namely that radiometric dating, carbon dating, uranium lead dating, there's lots of different kinds of dating methods. And radiometric dating methods indicate that the Earth is billions of years old. And do you guys remember the illustration I did with the water in the bucket?
Oh yeah.
Yeah, so just
And it dripped into
a
the
quick
pond.
review for Bella. Yeah, so here's an illustration of a faucet, and it's got it's got a valve there, and it's dripping water into a bucket. And here's your bucket right there, and water's dripping into the bucket, and you can measure the level of water in the bucket. And I think, what did we say? It was 100 gallons. Yeah.
Well,
Yeah, I think it was 100 gallons.
Okay. Yeah, 100 gallons. It's a really big bucket.
Like
And,
67 gallons.
And then we measured that this is leaking at a rate of 1 gallon per hour. And then we asked how long has the bucket been sitting there. So a quick bit of math would tell you that it's been there for 100 hours, right? If we're gaining 1 gallon per hour and there's 100 gallons in the bucket, Everett, put your phone away.
Sorry.
If you're gaining 1 gallon per hour and there's 100 gallons in the bucket, then that means that the bucket has been underwater, under this drip for 100 hours. Now, do we know that it was under there for 100 hours? We weren't there, but we're concluding it based on the evidence. But here's where this breaks down. For one, we are assuming that the bucket was empty when it started. What if the bucket was placed under there and it already had 90 gallons of water in it? Then it wouldn't have been there for 100 hours. It would have only been there for 10 hours, right? It's 90-gallon bucket, and now it's a 100-gallon bucket. Yes, Everett?
What if someone turned the faucet up?
That's the other big one, yeah. So the first major assumption, assumptions, there we go. Assumptions, the first one is initial quantity is known, which it is not. I'm just going to put initial quantity. And the other one is the rate of change.
67 changes.
And I thought of a third one just now. I remember I usually teach this as there's 3 assumptions, and I forget the last one. And the last one is undisturbed, because
41.
in addition to somebody turning on the faucet and then turning it off, and we're only measuring the drip after it turns off, and in addition to the bucket having water in it already before we put it under there, which we don't know because we weren't there, we're also assuming that nothing disturbed this bucket. Suppose somebody accidentally kicked the bucket over and had to set it up right, then the bucket has been there for a lot longer. So, what does this have to do with radiometric dating? I did not draw this conclusion, so this officially marks newer material. I did kind of indicate this, but radiometric dating comes from the fact that certain metals give off radiation and they change. For example, the metal uranium, I did draw uranium, didn't I? It's radioactive, right? So if you stay close to a piece of uranium for too long, you get cancer. That's because uranium is constantly emitting radiation. Yeah.
Don't you use radiation to get rid of cancer?
Yes.
Yeah.
If you target the radiation like kind of like a laser, and you aim only at the cancer, then you can kill cancer, and it's still very, very bad for the subject. But yes, it is. That's the same kind of stuff. And as it radiates, it changes. Uranium, it actually changes a lot. It changes to a whole bunch of different things. But where it finally stops changing is when it becomes lead, which is PB.
Personal best.
Yeah, well, plumbing is actually what PB stands for.
What's your
That's the Roman word for lead. Anyway,
6 pounds.
so what we do, boys, what we do when we do radiometric dating is we find a sample of rock, and it's got some uranium and some lead in it. And we take the whole thing, and we're like, okay, it is, I don't know, 10% uranium. I'm just throwing these out here now. 10% uranium. So that's that is equivalent to saying there's 100 gallons of water in the bucket. Is that our sample is 10% uranium, and we think we know the rate of change. We think we know how fast uranium turns into lead. And so using that, we have a rate of change that we assume we know, and we assume, of course, that this whole thing used to be uranium. Right? So it's mostly lead now, but there's a little bit of uranium. But way back in the beginning, maybe it was all uranium. And so we assume the initial quantity, we assume the rate of change, and then we get a really old age for the Earth. But suppose when God made this rock 6,000 years ago, it was only, 11% uranium. Then that drastically reduces how long this rock has been decaying, right? And so that's one of the ways by which radiometric dating fails. A more common kind of radiometric dating that you've probably heard of is carbon dating. Have you heard of carbon dating?
Yeah.
Oh, you date carbon? Yeah.
Yeah, it's the same thing.
We dated my grandma.
Yeah, so carbon dating is simply we start with we assume that there was a radioactive, what's called an isotope of carbon called C14, and it decays down into C12. But it's the same problem. Is we don't know for sure. The rate of change is a bit easier to assume with carbon dating, but what you definitely can't assume is the initial quantity. We don't know what the atmosphere was like, in the early Earth to assume that it had this much carbon-14 in it. I know I'm bouncing all over the place right now. I'm trying to review a complicated.
So what's the difference between C14 and C12?
There's 2 more neutrons in C14.
Oh, so it's more radioactive and less.
Yes, the extra neutrons make the whole atom unstable, and as it radiates, the neutrons decay into radiation that gets fired away. Okay. Let me see, where did I want to go from here?
You go to there.
I think I just want to talk about Darwinian evolution. Yeah, because the rest of this stuff doesn't really work. Sorry, I'm not more organized. Yeah. Okay, we're gonna go on to page 61 now. I mostly did this for Bella's benefit. Really, Daniel? Okay, so don't know how much it benefited her, but there you go. We are going to talk about Darwinian evolution today. So let's get that back on the board.
I'm on page 41 now.
It's lesson 15, page 61, actually. Yeah. No, just 61. Save it, dude. We're gonna hit 67 in like a week or two.
I took 7
Well,
pieces.
that's our whole
Have a little self-control. All right. So, what do we know about evolution? What assumptions does an evolutionary worldview make about the existence of God? What does an evolutionary worldview assume about the existence of God?
And evolution is a year?
Hmm?
Or is that a century? An evolution?
No. Evolution is the idea that all mankind evolved from nothing or from non-living matter. Huh? So what's their assumption about the existence of God? Okay, if you're asking that question, we need to take a step back here. So there are 2 competing worldviews about the origin of the world, okay? They are creationist and evolutionist. This is definitely a review from last week, but I guess you guys needed to review this part, okay? The creationist worldview is Bible-based, okay? Bible-based, but not unscientific. That's important to note, because a lot of people will say that we just throw out science in favor of the Bible, and that's not true. Evolutionist is, that worldview is science. I'll just call it science-based, because ultimately, science-based, but not always right. Maybe I'll put that there. The creationist worldview we've already mentioned. Age of Earth is 6,000 years. Come on. Age of Earth is millions of years, or billions of years rather. And what else? The creationist worldview recognizes that we were made with a purpose, right? If God made the heavens and the earth, give me the phone. Oh man.
You took mine. I don't. What the heck?
Now my pants are gonna be sagging. I'm gonna look like Everett. So I got two phones pulling my pants down. When God created the heavens and the earth, did he just make it and then walk away? No, right? He made it with a purpose. Yeah, Daniel. Gosh, you're such a turd. All right. So when God made the world, he had a purpose. Evolutionists believe there is no purpose. Everything is random chance. So the fact that you exist is really just because a lot of complicated physics has been going on for a very long time. That's your existence, huh?
I won the race.
You won the race, exactly. Yeah, I assume this is a sperm thing. Your sperm won the race, but also you won the race by being part of the human race. You won the race by happening to be a collection of organic machinery found here on planet Earth, which happens to be a friendly environment for organic machinery. But in the end, you are just something that arose. People say that when you think, you are just the universe thinking about itself. Have you seen the Disney Pixar movie Wish? Good, it sucked. But in that movie, there is a whole song about how you are a star, because long ago, at the birth of the universe, all the matter was condensed into stars, and you are descended from those stars. And so they try to make it sound really positive and happy and Disney-like that you're a star, because you come from a star. But the fact is they believe that is just totally random chance. It doesn't make you special at all. And that's why, and that assignment that I had you do where you take the perspective of an atheist, which only Daniel has submitted, by the way, and he had to do it twice. But there's that one assignment I gave you where you're supposed to take the perspective of an atheist, and a big reason for that is that you recognize that atheists believe that you are just random chance. You have no purpose. And anyway, all that to say that the evolutionist worldview, I should add to atheistic. I'll put theistic here. Theistic just means you believe in God. Atheistic obviously means you don't believe in God. The A prefix there means not or anti. There are people who believe in God and they think that God just used evolution, but that contradicts the biblical account. And that's why I specified that we are young earth creationists. I'm not putting that up there, but young earth creationists. We don't just try to shoehorn God into an atheistic evolutionary theory. We believe in God because he is the God of the Bible. And so that is why the evolutionary worldview assumes that there is no God. It is atheistic by nature, or at least if there is a God, he doesn't really care that much. What about the evolutionary assumptions about the natural and supernatural realms? It's that light blue speech balloon on your book there.
Yeah. What about it?
Yeah. What assumptions does an evolutionary worldview make about the natural and supernatural realm?
Jesus.
Well, you guys are just out of it today, aren't you?
I had knowledgeable today. He's on my thoughts. So.
Oh, you do knowledgeable.
Yeah, we got first actually. So.
Good job.
You can tell by my stuttering, I'm not making that.
Yeah. All right. What about you, Bella? What assumptions do you think the theory of evolution makes about the natural and supernatural worlds? Okay. Well, think about it. So if you believe that the universe is all there is, and that everything is a cosmic accident with no purpose, and that the only thing that you can trust is science. That is what you observe and what you learn from looking at things. What are you going to think about the supernatural?
And it's not real.
It's not real. Thank you. So the word for that is materialistic, or I'm just going to put materialist. Basically,
You're a materialist.
yeah, that does not mean that you care too much about material possessions or something like that.
Wiener for life.
What?
And what it means is that nature is all that there is. That the material world of matter, that's where the word material comes from. The world of matter is all that there is, and there's no more than that. We talked about the age of the Earth, and
74 billion years old.
yeah. Obviously the age of the Earth is going to be very different. Did I talk about uniformitarianism last week? I think I mentioned it.
Yeah, kind of.
Yeah, I'm going to put that down here too. Uniformitarianism. It's a big word. Uniformitarian. And what that means, this is stuff that you should be writing down, by the way, underneath the different balloons. Yeah.
Writing down on what?
Yeah, I don't know. You should come to class prepared, Everett. Don't blame me for your lack of preparation.
I don't prepare
Goodness.
anything.
Yeah, it
I'm
shows.
feeling bad.
All right,
That's
so
4 points.
maybe if you brought a pencil to class,
I
you
bring
would
a
not
pencil
fail.
to class.
Yeah, not to this one. So the evolutionist worldview makes a uniformitarian assumption, which means that the things that we measure now are the way they've always been. Remember the example I made about continental drift last week?
Oh, yeah.
So I mentioned that the continents move something like 5 inches per year, right? So
it's like 2 inches.
whatever it is, but I'm sure the drift is different for different continents. But you can measure that the continents actually move over the surface of the Earth, but it's ridiculously slow. It's just a couple inches per year. And then if you work backwards, you say, okay, well, 1 million years ago, it would be 1 million inches away from where it is now. And I don't know what exactly that is in feet, but it's a lot. It's a totally different place on the Earth. And of course, you can do this math with all the continents and model how they might have bounced off each
I
other
have a
over
pencil.
history and stuff. Good job, Everett. But the fact of the matter is uniformitarianism says that everything is always changing at a uniform rate. And so if we measure that rate now, we can learn about the past because we just assume that it's the same. For example, let's see here. We measure, let's say in the year 1970, we measure that the continent is, we're gonna call this, I don't know, or we'll call this 5 degrees off of the prime meridian. We're moving east and west here. And then in 2020, come on, 50 years later, we learned that that same continent is now at 5.05 degrees longitude. Let's do 4.95 because I want to make a downward curve. 4.95. Okay, so just the tiniest little difference. So here's 5 degrees up here, and then right down here is 4.95 degrees. So very, very, very slight decrease, but it's measurable over 50 years. Now, the uniformitarian assumption would say that if you go back in time, it's going to follow the same rate all the way back to the beginning, right? Does that make sense? That's the assumption. But we weren't there. We don't know. So suppose, 4,500 years ago, there was a giant flood that covered the whole earth with water and made all of the continents move very quickly and very suddenly. The movement of the continents might actually be something like this, where they moved a lot. First of all, they weren't moving at all, right? And then something big happened, like a worldwide flood, and that made the continents move around like crazy, and they've been slowing down ever since. And now we measure this rate over the course of 50 years, and we say, well, 50 years, that's a lot of data. That's like one scientist's entire career is 50 years. And this is the rate that he measured, so we can extrapolate that rate back and unlock the past using the present. But what we don't realize is that the present is not the whole picture. And since we weren't here, nobody was here to record it. Actually, they were, and the record ended up in the Bible, and now evolutionists say the Bible is myths and they throw it out. Or we're going to do a whole unit on the flood. Not a whole unit, a whole lesson on the flood. So I'm getting a little bit ahead of myself. But do you see the problem? The uniformitarian assumption says that we can know the past by measuring the present. And the reality is we can't. Because the past is different and we don't know what happened. Something as crazy as this, where the continents didn't move at all, and suddenly there's this huge upheaval of the continents, and they move quickly, and then they slow down. That is I'm not saying that we have proof of that. I think the evidence is pretty convincing. But what I'm getting at right here is that the uniformitarian assumption cannot take this into account. It just can't. And so you end up getting, if you base your worldview on this false assumption, then everything that you build on that worldview is also going to be false. And so that's what, I'll go ahead and put Noah's flood here, because that's the big thing. There is a lot of evidence for the flood, and we'll talk more about that in a future lesson. The last speech balloon on page 61 there talks about the difference between a theory and a law. I hate that, actually. Whoever wrote that is not a scientist, clearly. Because
Daniel, no more writing.
Huh?
What time is it?
Can you at least look at Daniel's book, Everett? Thank you.
What time is it?
It doesn't matter. It's time for you to pay attention.
Time for you to watch.
I
So-
had a phone, where did that go?
Yeah, where did I go?
I know, that's why I didn't say it's time for you to get a watch. Okay, so yeah, the difference between a theory and a law doesn't matter. Some people say, oh, evolution is a theory, not a fact. But that's kind of ignorant, so I'm not going to teach that here. What I am going to teach you, though, and this is very important, is there are actually two kinds of science. And they are operational science and historical science. And one of the biggest lies perpetrated by those who hold to an evolutionary standpoint is that these are the same. And they will often accuse us of being unscientific because we reject things like uniformitarianism and the old age of the earth and all of that stuff. Yes, Everett?
He's throwing on the table.
I'm not. Here we go again.
Gosh, what are you guys, two? All right,
I
so...
feel like
All right, I'm going to talk, all right, and if you fail to learn, then I will not confirm you. All right, so consider those consequences and deal with them. Gosh. So, the difference, two kinds of science. Operational science is, it's what you learn that science is when you're in like 7th grade. Operational science is conclusions drawn from observation and experimentation. So for example, if I take this nasty shirt and chuck it in this direction, Daniel does not move, right? But is that true every time? Here, Everett, toss it back. It was part of an illustration of this doesn't matter, right? So now so that's my one observation. I threw the shirt, Daniel didn't move, right? Okay, Daniel still didn't move. Does Daniel ever move? I don't know. Oh, he might move now. That's a dirty laundry shirt. Anyway, you can throw it back, Everett. So this is science, right? You do an experiment, you collect data, you repeat the experiment, you repeat the data, and eventually I conclude that Daniel's dead because he doesn't move. Ooh, Everett broke out the big guns there with a stinky sock. Very good. So that's enough of the stinky stuff. So that's what operational science is, right? An example would be if you react hydrogen gas with oxygen gas in the presence of heat, you get an explosion that leaves behind water. Okay, if you gather hydrogen gas and oxygen gas and give them enough heat, they will always explode and always leave behind water. That is a conclusion that is drawn from operational science, and you can count on that. That's how your car works. Only it's not hydrogen; it's octane. But that's how your car works. You react octane with oxygen in the presence of a spark.
Actually, it's ethanol.
Well, it's like 10% ethanol. It used to be octane. I know there's all kinds of new fuels out there.
Well, they also used to have lead too.
Okay, yeah, bear with me, all right? So the core reaction that drives a car engine is that with octane and oxygen in the presence of a spark plug. The spark plug provides the ignition, the reaction happens, it's a big explosion, it moves a piston. That is based on operational science. Somebody figured out how octane reacts with oxygen and what they can do with that explosive energy, and now we have cars. And the same principle can be said about electricity, light bulbs, construction, computers, phones, everything that we have, even paper. Everything that we have is built on operational science. And so, when Christians are mischaracterized as being unscientific or anti-science, we're being said that we deny the foundation of our society, and we don't. We absolutely do not. What are you doing, Daniel?
I'm giving my neck a massage.
Okay. Historical science, and I'm not saying historical science is bad, but it's different. Okay, historical science draws conclusions drawn by predicting isn't the right word because it already happened. By interpreting evidence. We'll just put it at that. Interpreting evidence. Alright, we're just going to leave it at that. I'm going to talk about it rather than writing it down. Historical science is conclusions drawn by interpreting evidence. So, for example, what's a good example? How many people died in the Battle of Gettysburg?
Like 1,000.
I don't know, but that's not a good one because we actually have like historical documentation. Let's go back further. When did the civilization in present-day China begin using ceramic pottery? That's a question that historical science might try to answer. Huh? I'm not asking you to answer the question. You don't know the answer. I don't know the answer. Oh, you don't? No. All right, let's go. What's the answer?
57 years ago.
67 years ago?
57.
All right, never mind. I thought we were going to have like an actual discussion here.
Look it up.
Are you trying to insult the Chinese? They've been using ceramic pottery for millennia. And I know that because archaeologists have dug up ceramic pottery in China.
No, but I thought we didn't know the answer.
From places that, well, we don't know exactly how long. That's the kind of question that historical science tries to answer. It's something that happened in the past, and even though modern Chinese people certainly know how to make ceramics, and 100 years ago they could make ceramics, 1,000 years ago, but at what point did they first learn that? At some point somebody invented what is now, China is what they call fine ceramics that come from the region of China. And you can't repeat that. You can't repeat history and see if that happens every time, or see if it's inevitable that people in that region of the world will invent ceramics roughly 5,000 years ago or whatever it was. You can't redo history. So historical science is fundamentally different than operational science because it tries to learn things that cannot be repeated, cannot be observed and repeated. When did the dinosaurs die? We don't know because there's no record of the dinosaurs dying. So what evolutionists do is they find dinosaur fossils and they say, aha, we have a fossil, we're digging up the past. But they're not digging up the past, they're digging up the present. Okay, the fossil is there now. And that is all we know about it from a purely scientific standpoint, is that the fossil now exists.
Yeah, but if it's deep in the ground, they would know that it was from a long time ago.
Right, so if it's deep underground, we know that the ground's, made layers over the top of it, but how fast did those layers form?
Probably not that fast.
Okay, probably not that fast. That's a big probably. Why not?
Because it doesn't happen that fast. Like
It-
that.
So you're saying that when we observe the rate at which sediments form into rock layers nowadays, it's very slow. And so if you assume that that's always how sediments form into rock layers, then we can assume that it must have been a long time ago for that many rock layers to form over the dinosaur bones, right? Yeah, and I'm telling you right now that that is the uniformitarian assumption, and even if it's likely, and we can, the word likely is pretty debatable, or probably, I think is the word that you used. It's not certain, and that's really important because the biblical account talks about Noah's flood, and Noah's flood can cause a great deal of sediments to deposit over a very short amount of time. And so we're going to be seeing Noah's flood as Noah's flood as a means by which a great deal of this stuff took place over a very short time.
What time is it?
650.
6, 7.
All right, 62 is
Over here.
come on.
He farted.
Turn to page 62. How many pencils do you have?
6.
Turn to page 62.
You took my work book, bro.
Alright, well, stop farting at him and maybe he'll give it back.
I ate
He was the
it
one
back.
that farted. It wasn't me.
Yeah, no. I may have eaten cheese, but that was not me.
Page 62 deals with the Big Bang Theory. And this is a basic thought exercise that should help you kind of see how to spot weaknesses in the evolutionary worldview. I know we haven't yet made a very strong case for the creationist worldview, but what I'm trying to do now is to get you to recognize that the popular evolutionist worldview is not as rock solid as everybody likes to say that it is, okay? It's historical science, which means that the conclusions that it draws cannot be verified, right? If I say something in a laboratory that is not true, you can prove it's not true by recreating those laboratory conditions and having it fail to happen. And then be like, hey, that guy told a lie. If I say something wrong in a historical science perspective, all you can really say is, well, the evidence doesn't seem to support that. You can't actually say with certainty whether something is right or wrong. All you can do is look at the evidence and try to piece together what happened in the past. And Daniel, you're pretty good at that when you try to engage your brain. I just wish you would do that more often. For example, the dinosaur bones being deep underground means that they must have been there for a long time. That's a very good way to interpret evidence. But it's not necessarily the only way, and it's not necessarily the best way. And that's what I want you to see, is that there's more than one way to interpret evidence. There's really only one way to do operational science. Either it works or it doesn't. But historical science has a lot of wiggle room, and it leaves room for doubt. And that's what we're doing as Christians, is we are doubting what the evolutionists are telling us. And the reason we're doubting that is because it goes against the Word of God. We have the answers in our Bible, and when we hear people say things that contradict what the Bible says, that should give you cause for pause. And when you do that, you realize there's a better way. We'll look at the better way next time. But for now, let's look at page 62. Big Bang or Big Bust? Bella, will you please read this for us?
Big Bang Theory states that all the matter in the universe was compressed into a small point until it finally exploded. But is the Big Bang really just a big bust? Below are some of the problems with the Big Bang Theory. Add one of your own.
Okay, you guys familiar with the basics of the Big Bang Theory? The whole universe was in a hot dense
Alright, you have to quote that.
I've already done that in this class, haven't I?
Yeah.
Yeah. Oh.
No, I'm the one that quoted it.
Okay. Well, anyway, that honestly, the beginning of that show is pretty much what the Big Bang Theory is. They speed things along, but they know they're speeding things along because the song literally goes really fast.
Is
Million years ago.
Yeah,
Because
so-
Sheldon's a believing God.
So, is that really surprising?
Yep,
Anyway,
yes.
check out some of the problems with the Big Bang Theory, right? So the Big Bang says that in the beginning, the whole universe was in a hot, dense state, and then it started expanding. But that still leaves the question, where did the stuff that started expanding, where did it come from? You know, all it really does is kick the can down the road. So an atheist says, God didn't make the universe, the Big Bang made the universe. Any thinking person should be able to respond to that and say, well, what made the Big Bang? And so that's a big weakness in the theory right there. The Big Bang defies the second law of thermodynamics. You guys learned that in school? I didn't learn it until college, so I don't
I
know.
learned about
Is
it.
it thermodynamics like
I learned
the
it in
cooling?
chemistry.
Is that the cooling of your car's engine block?
Huh?
Is it cooling on your car's engine block?
Is thermodynamic?
Yeah.
It's possible. Thermodynamics is the science of how heat and energy move. Thermo means heat and dynamo means power or movement or motion. So thermodynamics is literally how things move. And what the second law of thermodynamics says that things, whenever something happens, the world becomes a little more chaotic, a little more disorganized. So for example, even if I take all of my books here and stack them all up, I'm burning energy with my muscles and my mind and everything. And if you can quantify the amount of energy that I burn to put these books together, and what you'll find is that I burned more energy than the loss of entropy from doing this. Another way to think of the second law of thermodynamics is if I drop these books, what is the likelihood that they will be one on top of the other after they land?
50-50.
No.
50-50? Much less than that.
10-90.
Okay, so there's one. Boy, that's not a good, that's not a good start. There's one, they're one on top of the other. Okay, that one's on the floor. No, I mean like stacked. But Daniel had the right of it. So it didn't work. You know, you can decrease the loss of entropy if you're very, very careful. 1 out of 10 times. This Bible's starting to rip, so I'm not going to do this again. But the point is you intuitively know that things tend toward chaos. Things break. Your car rusts. You never have to worry about your car unrusting. Everything wears out. Everything gets.
Why would I worry about it unresting?
Because well, I guess you wouldn't worry about it, but you also don't look forward to it. You're not like, oh boy, the car is rusted, but it might unrust.
Have you ever seen a cab mounting bolt rusted so far through on a 2000 Chevy?
No, I have not. But
I went to torque that and it just snapped.
Yeah, that's the second law of thermodynamics right there. You tried to fix it and it made it worse. So anyway, there is an actual scientific quantification of how the universe tends toward disorder, and that is observational science. That is well documented and well understood. And the Big Bang Theory throws all that out the window and says, in order for the Big Bang Theory to be true, we can't have the second law act like it does. So we have to rewrite that and pretend like the laws of science were somehow different in the early years of the universe. And furthermore, the third balloon there, the precision and order of the universe speaks against the random disorder that would be caused by a Big Bang, okay? When you blow something up, you don't expect things to fall together, organized. If a tornado goes through a junkyard, you don't expect it to throw all the pieces in just the right place to assemble a working car. You expect it to throw junk all over the place, and that's what happens. And the Big Bang Theory basically says that a tornado went through a junkyard and everything came out looking better than when it went in. And that defies the second law of thermodynamics and intuition and like every form of observational science. So there's a lot of problems with the Big Bang at a foundational level. And those who defend the Big Bang, they literally have to invent things to make it work. Have any of you ever heard of dark matter or dark energy? It's in vogue in science right now. The scientists believe that there's a whole bunch of dark matter and dark energy out there that for some reason we can't detect. It's not like that it's just not lit up by something. It's that we literally, it doesn't interact with any way that we have to observe it. The only reason they think it exists is because they realized that for the universe to be as old as they think it is, it has to exist. And anybody want to guess what percentage of the universe is theorized to be made up of dark matter? How much of the universe is dark matter?
Oh, probably half of it.
About half of it, you think? Anyone else want to take a guess? Remember, we can't observe this at all. As far as we know, it's not there. It's only there because it has to be. What'd you say, Everett?
90%.
97%.
I was going to say 98.
97% of the matter in the universe must be dark matter in order for the Big Bang Theory to make sense with the world we observe today. That's huge because we can't observe it. It's not there. We can't see it.
So we're less than 3% of what Earth.
Huh?
We're less than 3% of Earth.
Yeah, well, it's not so much Earth. Earth is not dark matter. At least I don't think it is. Yeah, the point is that dark matter was literally invented. It's called a fudge factor. In order to make the math work for the Big Bang Theory, they had to say that 97% of the universe is there, but we can't detect it in any meaningful way. So stuff like that should really make you stop and think, could it be that 97% of the universe is invisible to all of our instruments? Or could it be that we're just wrong about how the universe formed? And that's the issue, is that people don't want to admit that the Big Bang Theory is a load of baloney. And so they have to,
You eat the Big Bang Theory?
as we learn more about the universe, we have to modify the theory so much that it becomes laughably unbelievable.
What time is it?
It is 7 o'clock.
Yeah.
Next time we're going to talk about the evolution of life. I promise I will be more prepared. Let me hand out a few things before we say our closing prayer.
I thank you, my heavenly pastor.
I'm not your heavenly pastor, I'm just your pastor.
I thank you.
Let me hand out the stuff and then we'll say our closing prayer. And then I have graded papers to hand back as well. First of all, I want to give you an invitation. This Friday.
Lock in! Yeah!
It's not a lock-in this time, sorry.
Is
This
it a lock-in?
Friday is Halloween, and we're having a Halloween party from 8 to 11. This is only for youth in grades 7 through 12.
Is there a lock-in?
can't
Is there a lock-in this year?
We're hoping to have a lock-in in the spring, but it didn't work out for the fall.
Daniel
Dang it.
can't bring his girlfriend.
Secondly, here is
I can't purple.
your memory assignment. Yeah, there's an extra one for Bailey, but give that one to Daniel, please. Everett.
Thanks, Edward.
And then your homework for tonight is going to be reading another article for next Wednesday.
Oh!
You're going to read another article that is called 6 Evidences for a Young Earth. And this article has it's pretty light stuff. It's only 2 pages and it presents 6 evidences of a young Earth. So read that article, answer the questions about it, and we will talk more about it next time, as well as get into a discussion of the evolution of life. But for now, let's close with the Lord's Prayer. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. For thine is the kingdom, and the power, and the glory, forever and ever. Amen.